Friends, welcome back to the YouTube channel. So in this video I'll explain you about the OOP, that is object oriented programming lab assignment 1 of second year information technology. So we'll first see the problem statement of the assignment. So the problem statement of the assignment is to design a class complex with data members for real and imaginary part, provide default and parameterized constructors, and write a program to perform arithmetic operations of two complex numbers. So we'll divide this problem statement into some parts. So first we have to create a class which will have a name of complex, and in that class we'll have some data members. So what are data members? Data members are nothing but the variables of the class for real and imaginary part. So for real also we have to create a variable or a data member, and similarly for the imaginary part. So now what is this real part and imaginary part, that we'll see in the next slide. Next is to provide default and parameterized constructors. So what are constructors, that also we'll see, and in that we have to use the default and parameterized constructors. Then we have to perform the arithmetic operations on this complex numbers. So which arithmetic operations will we can perform? First is the addition, then subtraction, then multiplication, and then division. But in this video I'll only show you about the subtraction, multiplication, and addition. And for division you can just check out the formula, and the other steps will be same. So now let's see what actually the complex numbers are. So basically the complex number are nothing but the numbers which are in the form of a plus bi. So now what are these a plus bi? So you can split this into two parts. So first is the real part and second one is the imaginary part. So now real part is denoted by this a here, and the imaginary part can be denoted by bi. So here a and b both are the real numbers, but here I, which is attached with b, makes this bi as a complex number. Okay, so now here the value of I is nothing but the square root of -1, so that is square root of -1. So whenever we have the problem of finding the square root of negative numbers, so in that case the idea of the complex numbers comes. So we'll understand this with the help of an example. So here we have the complex number which is 2 plus 4i. So here if you compare this number with this complex number standard form, you'll get the real part which is a equal to 2 and the imaginary part is equal to 4i. Now we'll understand actually how this 4i comes here. So first we'll equate this is equal to 16 into -1, so which is nothing but the square root of negative minus 16. Okay, so now the square root of 16 is nothing but 4, which will come out of from the square root, and we'll have -1 inside the square root. And now this square root of -1 whole term is considered as I, or which can be represented by I. So this is the concept of complex number. Basically you have two parts, real part and imaginary part. Real part is denoted by small a and imaginary part is denoted by bi. So where I is nothing but the square root of -1. Okay, so this is about the complex number. So now we'll move to the implementation part of this assignment. So now I'll move to the my Eclipse IDE. So as per the problem statement, we have to make use of the constructors. So I'll paste the problem statement here so that it will be easy for us to write the program. Okay, so we have to create a class complex, right? So first I'll directly create a class with complex name. And now inside this class we have to create its data members. So now data members are nothing but the variables. So we'll create two variables because in the problem statement they have mentioned with data members for real and imaginary part. So for real I'll write double real. I'll not give any default value for this. So then double imaginary. So imaginary part I am denoting it with img. Okay, after that we have to provide the default and parameterized constructors. So basically constructors are used to initialize or to create the objects. Okay, so whenever you will create the object, it will automatically call the default constructor if you haven't created any constructor. So here we'll provide both the constructor, that is default and parameterized. So basically if we do not provide any constructor, then the compiler will automatically call the default constructor. So there is no need to create the default constructor. Okay, so here we can create the no argument constructor. So for that, what you have to remind is the name of the constructor is same as that of the name of the class. Okay, so here I have given the class name as complex. So with the same name only I will create a constructors. So first I'll give the access specifier or access modifier for this. So it is public so that it can be accessed from anywhere. Then the name of the constructor, which is complex, because our class name and constructor name should be same. And then it is no argument constructor, so I am not passing any of the parameters for this. And then inside this I am setting the value of this real data member as equal to 0 and imaginary as equal to 0. So even if you don't write this, then also your program will be executed, but in the problem statement it is given, so we have writing it. Okay, next we have to create a parameterized constructor. So now parameterized constructor is nothing but we pass the parameters inside this parenthesis as we pass in the methods. Okay, so in methods also we'll pass some parameters along with their integer or the data types. So similarly here we'll pass some parameters to our constructor. Okay, so here constructor name will be same as that of the class, and remember one thing, that the constructor don't have the return type. So what do I mean by return type? So in some cases you will see here we write some, suppose public int, then public void. So these are nothing but return types, but constructors don't have return type, so that is important to remember. Okay, next is to pass the parameters. So here I'll pass the parameter as, suppose double, because we want to accept this from the user. So double R, which will store my real part, and then double I. So here I have taken the double data members, data type of the real and imaginary is double. So you can take it as float also or integer also. So after that we have to set the object of this real and imaginary equal to this whatever we are passing here. Okay, so for that I'll make use of this keyword. So this dot real is equal to R and this dot imaginary is equal to I. Okay, so whenever I'll pass some values inside this constructor, or whenever this constructor is called, then whatever the values you are passing in this R and I, that will be initialized with this real and imaginary. Okay, so that's why we are using this keyword. So if you don't use this keyword, then the compiler will get confused whether to consider this value or the default values or whatever values you are passing here. So we have to use this keyword so that the compiler will be able to understand that whatever values you are passing as a parameter inside this constructor, that only you have to use here. Okay, so this is about our complex class. Now next is to create our arithmetic operation, to perform the arithmetic operation. So for that I'll create class with public class, and the name of my class will be same of my file name. So I have given the name as Assignment-1. Okay, so now inside this we have to create the public static void main method. So as we do, so for that I'll write here public static void main. In that we have to pass the string array with name args, and then inside this we have to now accept the user inputs and make the methods and then call the methods. Okay, so here I'll take the input from the user. So for that I have to import the scanner class. So import java.util.scanner, or you can directly type here star also, so that it will import all which is present inside this util library class. Okay, but here for example I'll only use the scanner class. Okay, then next we have to create the object of this scanner class. So for that I'll write scanner. The name of the object is sc, or you can write scan, anything you want. So I'll keep it as sc is equal to, then new, which will create an object scanner and in round brackets we have to write system.in. Okay, so here also we are creating the object of the scanner class, and here whatever you are seeing here, scanner and then round brackets, so this is nothing but the constructor. This is constructor and this is nothing but the name of the class. Okay, so now we'll now accept the input from the user for our complex number. Okay, so for that I'll write system.out.println, and then I'll display some message to the user so that they will understand what exactly they have to enter. So here I'll write enter the real part of first complex number, or you can write here of complex number 1. Okay, and then I'll store it in some variables. So I'll store it in double and write here comp1 underscore real is equal to, now I'll make use of the object that I have created for the scanner class. So sc dot next, and we are accepting the double variables, double type of data. So for that, next double. Okay, similarly we'll do for the imaginary part and for the second complex number. So I'll copy this, paste it, and just I'll change the wordings here, complex number 2, and here instead of real I'll write imaginary. Then here also I'll change it to imaginary or ing, and here I'll make it as 2. Okay, so now we have accepted two complex number. So each complex number has real part and imaginary part that we have stored in different variables. Okay, so now after this we have to create the object of our this complex class. So for that we'll create here two objects. So for that we have the syntax, that is the name of the class, my class name is complex, is equal to name of the object is comp1, that is complex number 1, is equal to new keyword which will allocate memory for this object, and again constructor. So constructor is my complex with parameter. So here I'll pass which parameter, this complex 1 real and imaginary part. Okay, so here I'll pass comp underscore real comma comp 1 underscore imaginary part. Okay, so 5 we have passed two parameters because here we have defined the constructor complex which will have two parameters r and I, which are of double data types. Okay, so for that we have passed here two variables. Similarly we'll do for the second complex number. So again I'll create new object which will have the names com2, that is second complex number, and just we have to change the values here. Okay, so I hope till this you have cleared what we have done actually. Okay, so now after this we have to create the methods for addition, subtraction, multiplication and division, but for this I'll only explain about the addition, subtraction and multiplication. So for that also we have to create some variables so that our result will be stored there. So for that I'll write here complex and then sum. So this complex is nothing but our data type. So basically classes are used to create the user defined data types. So here we are creating our own data type. So for that we have written here complex sum is equal to, then so instead of sum I'll write here add output. So addition output is equal to, then I'll create some method that is add in bracket I have to pass the two complex numbers. So now my complex number is nothing but com1 and com2. Okay, com1 and com2. These are my two new complex numbers. So here only we have taken the real part and imaginary part, and that we have combined inside this com1 and com2. So that I have to pass here. Okay, so now similarly I'll do for the subtraction and multiplication. So for that also I'll copy this. Okay, and I'll also comment for the division so that you can try it of your own. So addition, subtraction and multiplication. Okay, and here you can code for the division. Okay, so I'll just comment it. So here I have to pass the create the function for multiply, and here for subtraction, and here I will create for addition. Okay, so what we have done here, we have created one object which will have the name as add underscore out, so which will store our addition out result. Similarly for subtraction and multiplication, then we have created method, just we have called here the method, but we have to write the code for this individual methods. Okay, so addition, and this will have passed two parameters, that is complex number 1 and complex number 2. Similarly for subtraction we have passed complex number 1 and complex number 2, and for the multiply as well. So now we'll write the code for this addition, subtraction, multiplication after our this main method. Okay, so outside this main method we have to write this code. So now this main method closes here, so below that I'll create the methods called addition. So for that I'm writing it as static uh, public static complex, so because it is of complex data type, right? Public static complex, then addition, and it will have two parameters which is of type complex as well. So I'll write here complex com1 comma complex com2. Okay, now inside this I have to write the definition or the code for this. So for this we have to again allocate the memory for our output. Here we are only declaring here that we will have some this variable, but the memory is not allocated here. So for that we have to allocate the memory. So for that I'll write here complex, then add underscore out is equal to new, and then again I'll call the constructor, and in that I'll pass the values as 0 comma 0. Okay, so initially it will have 0 comma 0 in the add out, that is real part will be 0, imaginary part will also be 0. Now after that we have to make the addition or perform the addition. So for that you have to remember the formula. So I'll write here formula for addition so that it will be easier for you to understand. Formula for addition. Okay, so here we have seen the standard form of the complex number, which is a plus b I. This is my first complex number, and second complex number is c plus d I. Okay, so this is my second complex number. So now if we add this, we'll get the output as a plus c. Okay, so a plus c, real parts real addition of the real parts with the real part, and plus addition of the imaginary part with the imaginary part. So here imaginary part is nothing but b plus d. Okay, so whatever output you will get, that is nothing but your addition of these two complex number. Okay, so now this only will use for our formula. So here I'll create one variable I have already created, that is add out. So I'll write add underscore out. So inside the add out real part, what we have to store? Addition of the real parts. So my first complex number is com1, so that real plus whatever the com2 is there, whatever the real part it is having, so add that and store it in the add out real part. Okay, so similarly we have to do for the imaginary part as well. So here I'll write, instead of real I'll write imaginary part, then com1.img and com2.img. Okay, so here I have stored the real addition of the real part and addition of the imaginary part in the add outs real and imaginary part respectively. Then finally I have to return something because I have given return type as complex, so it should return some values which is of complex type. So here my complex is nothing but add out. Okay, so this is about the addition. So similarly you have to do for the subtraction. So I'll copy this whole code and paste it here, and I'll just change the name here from addition to subtraction. Then here I have to write sub out. Then here also I have to write sub out, and here also sub out. Again from here I have to return sub out. And the formula, only difference between the formula is the sign of subtraction, because here just it's this, and here also a minus c, here it's a plus c, sorry, a plus c, and here b minus d. So this is the formula for subtraction. Okay, so we have performed the addition and subtraction. Similarly you have to perform the multiplication. Okay, so for that also I'll write the same code. So just I'll change here multiplication. What we have created the method as multiply. Okay, multiply. Okay, then here I have to write mul out. Okay, then now multiplication formula, will see how actually it's done. Okay, so here as we perform our multiplication, similarly here also we have to perform same, nothing difference. But okay, so here a plus bi into c plus di. So here first a will be multiplied with c, so we'll get the output as ac. Then plus sign, so plus sign, then a into di, that is nothing but a di. Okay, so I'll get a di. Okay, then next is what, bi into c, that is nothing but bci. Okay, so I'll write here plus bci. Then next is what, bi into di, so that is nothing but bdi square. Okay, so for that I'll write here b d and I square. Okay, so I square. This also you can write in the same, so that it will be easier to understand. So this I square, now we have seen that I is equal to under root of -1. So if you take square of it, it will be -1. Root and square root will be cancelled. So here instead of this minus I raised to -2, you can write -1. Okay, so that we have to do here. Now see here, a is nothing but our first comp1 real part, and c is nothing but our second complex numbers real part, so that we have to multiply. Okay, so I have multiplied. Then next what we have to do next is plus a, that is comp1 real part, into my d is nothing but my comp2's imaginary part. Okay, so here what I have done, yeah, comp2 imaginary part. Okay, so dot img, com1 real into com2 real, and then in you can also mention the brackets. Okay, so that it will not make any confusion to you. This plus com1 we have done with a into c, plus a into di. So a is nothing but com1 real into d is nothing but my com2's imaginary part, and then next is into -1. Okay. Okay, wait a minute. What we'll do is we'll separate out the imaginary, that is I terms and single real terms, because it is making confusion. Okay, so I'll write this again. It can be rewritten as a plus c, and what the part is bdi square, that is nothing but ac minus bd, right? AC minus bd. So this is my first. Then second, we left with now ADI plus BCI. Okay, so that will combine in the first part. Okay, so ADI and BCI. So from this also you can remove the I common, and then AD plus BC. This will be more easy for you to understand. Okay, so what we have done is just we have separated the real part values into single columns and imaginary into the other brackets. Okay, so now it will be easy for us. Okay, so first is a into c, that is nothing but com1 real into com2 real, and then minus, so minus is nothing but the output. So for that also you can here mention that plus, and then again bracket bd. Okay, so more complex, it's we are not getting into directly computation, so we'll just make it as simple as possible. Then second is bd. So b is nothing but our minus. Okay, so it's minus, so for that we have to multiply it with -1. So I'll write here -1 into -1 into which terms we have, b into d. So b is nothing but my com1 imaginary part. Okay, so com1 imaginary part, so dot ing into, next is what, d. So d is nothing but what, my com2's imaginary part, so com2 dot ing. Okay, I hope this is clear to you. So just go with the formula, then it will be easier for you to understand. Then next, for the imaginary part, we have the imaginary part as a into d. So a is nothing but our com1 dot real part. Okay, com1 real into d, that is nothing but com2's real part. Sorry, d is nothing but com2's imaginary part. Okay, it's imaginary part. Then after that we'll have plus sign, and then we have b into c. So b is nothing but com1 imaginary part. Okay, sorry, com1 imaginary part into c. C is nothing but com2 real part. Okay, so this is the formula for multiplication, and finally we are returning the result with the help of return statement, that is return mul underscore output. So for the first time this looks complicated for you to understand, but if you practice it one or twice, then it will be easier for you to understand. So similarly you can do for the division is a little bit difficult. So for this, okay, formula is difficult. Just once you get clear with the formula, then it will be easier to implement. So for division also I'll show you the formula. Okay, so for that I'll write here complex number division. So see here, for the complex number division we have the formula something like this. Okay, so what you can do here is you can first make the denominator. Okay, you can make find the LCM of that. So for that what you will do is a into c plus b into d, then again multiply this term, then plus again this term into this term, and in division you will have the multiplication of these both terms. Okay, so here they have done it. Okay, in this way you have to do, and then you have to calculate the denominator separately. Okay, and then just divide this whole term by this. So you can just check out this link or any other link in which you will find the example more easier, so that you can choose. Okay, so we have done with this three functions. Now we'll move to the displaying of our result. Okay, so just we have stored the result, we haven't displayed any result yet. So for that, in the main function, now what I'll do is I'll display the statements. Okay, so for that I'll write system.out.println, and inside this I'll write first complex number is, and then first complex number is a combination of complex one dot real plus imaginary part. So for that I'll plus sign, plus, then plus, and then in brackets I'll keep it in brackets. Okay, and then here I'll add the imaginary part, comp1 imaginary part, and then again I'll concatenate it with bracket. Okay, okay, so this is my first, and inside that we have to add the I. So because a plus bi, so I we are have to add it. So this is my first complex number. Similarly I'll do for the second complex number. So copy, paste, and for the other outputs also. Okay, so first complex number, here it's second complex number. Second complex number is nothing but a comp2 dot real and comp2 dot imaginary. Then here we'll display the results. Okay, so displaying results of arithmetic operations. Okay. So first is nothing but addition. So addition of two complex number, or addition you can directly display it. Addition is, then subtraction is, subtraction is, and then division. Division is. So for that, instead of this comp1, we have the result stored in our add underscore out. So add underscore out dot real plus add underscore dot real imaginary. Okay, so add underscore out imaginary. Similarly we have to do for the subtraction, sub underscore out, and for the multiplication also. Okay, so here I have written division, it's multiplication. Okay, so we have completed with our code for this. Okay, so we'll now run this and we'll see if we have some errors or not. So here I'll save this, continue, and then I'll run it. So here I have to enter the real part of my first complex number, so I'll take it as simple numbers so that it will be easier for us to calculate manually. 5.0, second imaginary part of the complex number 2, so I'll keep it as 4.5. Then real part of the second complex number. Okay, we have done some mistake in the statements display. Real part of first complex number, imaginary part of first, here it's first. Then here real part of second complex number, and here also it's second. Okay, and here I have taken the new line, so I'll remove this new line so that it will be accepted in front of this statement only. Okay, I'll save it and now I'll run it. Okay, so first complex number real part, so it's suppose 5.4, then imaginary part is suppose 4.6, then real part of this second complex number is suppose 8.0, and imaginary part of the second complex number we can keep it as 3.2. So first complex number is 5.4 plus 4.6i, correct. Second complex number is 8.0 plus 3.2i, correct. Then addition, so addition, what I have to check this 5.4 plus 8.0, so it's 8 plus 4 12 13 13.4, right, plus imaginary parts addition, so 4.6 plus 3.2, that is 7.8, so it is also correctly displayed. Second subtraction, so real part minus this real part, so we have to we are getting the same answer, right? So I think we haven't changed the sign here in the subtraction, yeah, here we have to make it as minus. Okay. Now it will be correct. So these are some errors that you will get when you perform this assignment, so make sure you practice it. Okay, so first is 5.1 plus 4.5, I correct. 6.2 plus 8.0, I correct. Then addition is 5.1 plus 6.2 is 11.3, correct, plus 4.5 plus 8.0 is nothing but 12.5, correct. Then subtraction, 5.1 minus 6.2, which is nothing but 1, right, minus 1.1, right, and it's we have taken the double, so it will display this much integer or the decimals, digits after the decimal, 15 decimals. Okay, so that you can reduce by float also. Then next is multiplication, so it will be correct. Okay, formula is correct, then it will be correct. So this is the assignment 1 of your lab assignment of OOPS, or object oriented programming. So I'll revise or make a summary of this. So first we have imported the scanner class, so which will be used to take the user input. Then we have to create the complex class, so I have created the complex class. Then inside that we have to create data members for real and imaginary, so I have created it double real double imaginary. Then we have to create constructors, so I have created two constructor. First is the no argument constructor, so in that I have initialized the value of real and imaginary to 0, and it remember that constructor name is same as that of your class name, and it does not have any return type, not even void also. Okay, then I have created the second constructor, which is parameterized constructor, where I have passed two parameters, double r and double I. So and then I have initialize these two objects with this using this keyword. So this dot real equal to r, this dot imaginary equal to I. So we make use of this keyword to avoid the ambiguity or to confusion for the compiler to exactly know which variable or which data member we have to use. Okay, so this is about our class complex. Now we have created the class of assignment 1, inside which we have created our main method. Then we have created the object of the scanner with name SC. Then we have displayed the statement to the user to enter the real part of the first complex number, stored that result into the comp1 underscore real variable, which is of double data type. Then we have used the sc.next double because the user is going to enter the double data type, okay, value which is having the double as a data type. Similarly, we have accepted the inputs for the imaginary part of the first complex number, real and imaginary part of the second complex number, and stored it in the respective variables. Then we have created the complex objects, that is comp1 and comp2, and we have called the constructor, which is a parameterized constructor, and pass the two parameters, that is comp1 underscore real and comp1 underscore imaginary, and then these both are combined and stored in the comp1 variable or the object. Similarly for the comp2, then we have here define the methods for addition, subtraction and multiplication. So for that also I have created one variable, that is add out, sub out and mult out, so which will have the respective output stored inside them for addition, subtraction and multiplication. So in addition we have to perform the addition of two complex numbers, so that's why I have passed the two parameters com1 and com2, because this is nothing but our complex numbers. Okay, similarly for subtraction and multiplication. And then finally I have displayed here the results. So first complex number is this. Complex number is a combination of real and imaginary, so that I have just displayed here. And whatever I have written in the double quotes, that are nothing but strings, so that will be displayed as it is you have written inside double quotes. Similarly, second complex number is also displayed here. Then here we have displayed the results, so that the addition is, then whatever the result we are getting inside this add out, that I have displayed here, real, then add out imaginary. Similarly for subtraction and multiplication. Now here we have only called our methods, but we haven't written the code for that, so that I have written inside this main method. So make sure that you close this main method first and then you write the code for the methods. Okay, so that I have closed here, and then I have written the three methods: addition, subtraction and multiplication. So public static complex addition, complex comp1 comma comp2. So whatever parameters you are passing, they are also of complex data type, and here the return type is complex. And this static keyword is used because we are not creating the object of this addition or the class to call this method. Okay, here we have directly called the name of the method and passing the parameter. Then I have created the object add out, and I have initialized the values to 0 comma 0. So real is 0, imaginary is 0, by calling this complex parameterized constructor. Then formula of addition is here, and then inside this add out dot real part I have stored the addition of the two complex numbers real part, comp1 dot real plus comp2 dot real. And similarly for imaginary part I have done here, and whatever the results are now inside this add underscore out, that I have written here using return statement. Okay, so from here whatever the value will be returned, that will be stored inside your this object. Okay, inside this object. Similarly we have to do for the subtraction and multiplication. Just go through the formula and practice one or twice. You will be able to solve this assignment easily. So this is about this assignment. So if you have any doubt, let me know in the comment section, and if you get any error or any compiler error, then just mention that in the comment section. I'll definitely try to solve that errors. So thanks for watching. We'll see in the next video. Till then, keep practicing, keep learning.